Hello there, and welcome to week 7. More logarithms this week. Let's take a look. Section 4.5, properties of logarithms. So these are the properties I mentioned last time, and I have them written down here. You really do need to memorize them. Make some flashcards. The homework problems involve either combining or expanding logarithms using these properties. I think you'll find that section very straightforward. The next section is logarithmic and exponential equations. So I have that mislabeled, logarithmic and exponential equations. There are two videos. One is just an overview of solving logarithmic equations with a bunch of examples, and the other is solving exponential equations using logarithms with a bunch of examples. I would suggest watching them both. I want to point out a couple of things. One, when you solve any equation using logarithms, you always have to check your answer. And that's because the properties of logarithms that I have above are only valid when these things are defined. So x and y are both positive. And so let's take a look at what happens when we solve an equation that involves logarithms and we have to use properties of logs. So the first thing we're going to do here, and in video 1, there's some guidelines for solving equations that have logs. And the first thing is to combine logs if there are two logarithms on one side. So using properties of logs, this is ln, a single log, of the product of x and x minus 2, which is x squared minus 2x. And that's equal to ln of 5x. Now, the natural log function is 1 to 1. So if ln of a equals ln of b, then that implies that a equals b. So at this point, I can just set x squared minus 2x equal to 5x. Now, solving from there, subtract 5x from both sides. And finally, factor. X times x minus 7 is 0. So seemingly, I have two answers. X is 0 and x is 7. But actually, I don't. Because if I go back and look at this original equation, it's not even defined when x is 0. You can't take log of 0. And you certainly can't take log of negative 2. So this guy goes out, and we actually only have one answer. All right, and another thing I want to point out about this section is I'm going to require that all your answers are exact. Now, here's a problem right from your homework. Solve 4 to the x equals 50. If you click on the answer key, you'll see a decimal. That doesn't mean you can enter a decimal for your answer and get it right. This is a decimal representation of what the actual answer is. So I'm going to show you how to solve this. There are a couple different ways. I'll do the better way first using natural logs. Take the natural log of both sides. And now use the property of logarithms that says ln 4 to the x is x ln 4. That's property 3 in that list above. So finally, divide both sides by ln 4. X is ln 50 over ln 4. And if you enter that in this box, you will get it correct. Okay? So I think that's the preferable way to do it. The other way to do it would be, we've got 4 to the x equals 50. You could use log base 4. 4 to the x equals 50. If I take log base 4 of both sides, log base 4 of 4 to the x, sorry, I'm screwing up here, 4 to the x is log base 4 of 50. Now, log base 4 of 4 to the x is x, because log base 4 undoes exponentiating with base 4. So I get x is log base 4 of 50. You could also put that in the box and you would get it right. Now, why is the first answer preferable? Because if you actually needed a decimal approximation, suppose you're sending a person to the moon and you for some reason you need a decimal approximation of this number, you're not going to be able to do it with this. You're going to have to use natural log or common log. Your calculator, hopefully you have something a little bit more sophisticated than a calculator if you're sending someone to the moon, but nonetheless, they did it with slide rules back in the day. Natural log is preferable. Okay. Section 4.7, exponential and logarithmic models. I took out all the video lessons because they were just confusing. There's a video for each problem you have to solve, and you can just click on that. Pay attention to things like half-life. All of the problems can be solved using this one equation. And typically, these are going to be multi-part problems. Like, you won't be able to solve the answer right away. First, you'll have to find K, and there'll be a lot of information given. So these will be typically long problems. Again, you're going to need to give exact answers, and these will be rather long exact answers. So your answer might be like e to the 1/3 ln of 57 over 4. That would be an answer. Or it might be something like 28 ln of 2/3 divided by ln of 7 over 8. That would be a valid answer. So just find your answer in exact form and enter that. Again, if you click on the answer key, you'll see a decimal approximation of what the answer should be. So you can check your answer that way. Like if you're wondering if you got it right, well, the computer will tell you, but you can also put this in a calculator and see if it agrees with the decimal approximation you're getting from the computer program. All right, have a great week. That is the end.